Today I'll be talking about pressure-volume loops and the time domain in relation to the heart. Taking a look at point number 1 on the graph, this occurs right after filling of the left ventricle. It is also called the end diastolic volume. This is where the left ventricle pressure is greater than the left atrium pressure. The mitral valve and the aortic valve are closed. Moving from point 1 to point 2, the heart is in isovolumic contraction. At point 2 on the graph, the aortic valve is opened and the mitral valve is closed. This is because the left ventricle pressure is greater than the aortic pressure and the left atrial pressure. Moving from point 2 to point 3, the heart is in the ejection phase. At point 3 on the graph, the aortic and mitral valve are closed. This is because the left ventricle pressure is less than the aortic pressure, but it is greater than the left atrial pressure. Moving from point 3 to point 4 on the graph, the heart is in isovolumic contraction again. At point 4 on the graph, the aortic valve closes and the mitral valve opens. This is because the left ventricle pressure is less than both the aortic pressure and the left atrial pressure. This point occurs at end systolic volume. Moving from point 4 to point 1 on the graph, the heart is in the filling phase. From the graph, we can get very important equations. For example, the power is equal to the external work divided by the change of the heartbeat. Instantaneous power is equal to the change of pressure plus the change of the flow rate. The systolic volume is equal to the difference between the end diastolic volume and the end systolic volume. The ejection fraction is equal to the stroke volume divided by the end diastolic volume, or 1 minus the end systolic volume over the end diastolic volume. This leads us to Starling's law of the heart, which states that the stroke volume of the heart increases in response to an increase in the volume of the blood in the ventricles.